Hello everyone, welcome back. So let's continue solving the questions on RegulaFalsi method. So in the previous videos we have solved bisection method and questions on RegulaFalsi method. We have learned how to solve them. So now let's continue solving the RegulaFalsi method questions. The question here is find real root of x e power x minus 2 is equal to 0 correct to 4 decimal places by method of false position. So what is our f of x? F of x is equal to x e power x minus 2. Okay. So here in the question we are given as by method of false position. So method of false position and RegulaFalsi method are same. Okay. So let's not get confused here. So both are same. What is our first step in solving the questions? So first step is we have to find the values of a and b such that f of a into f of b will be less than 0. Right? We have to find two numbers a and b such that when you find out f of a and you find out f of b and we multiply both of them, the value will be less than 0. So that means one value should be a negative number and the other one should be a positive number, right? So negative multiplied by positive is negative, which will be less than 0. So f of a times f of b should be less than 0. So now let's find out those numbers. Let's see what is f of 0. F of 0 is 0 into e power 0 minus 2, which is minus 2. So this is less than 0. Now let's try what will be f of 1. F of 1 is 1 into e power 1 minus 2. So the value is 0.7183. This is greater than 0. So we have one number which is less than 0 and other number which is greater than 0. So f of 0 into f of 1 will be less than 0, right? F of 0 into f of 1 is less than 0. F of 0 is negative, f of 1 is a positive number. So we have found out two numbers, right, a and b, which is satisfying this condition. So this will be our first interval. So our first interval would be 0, 1. So first interval is 0, 1. So in the table of RegulaFalsi method, what we will be having? I is the iterations. We have noted down I here because in some of the questions, as we have seen in the previous problems, that they'll just ask us to solve 4 iterations. So sometimes we'll just find the root. Sometimes they'll ask us do in 4 iterations or 5 iterations. So that's why our first column is I, which is iterations. Next is interval. Next is xi. Finding xi in RegulaFalsi method is a into f of b minus b into f of a by f of b minus f of a. Right? What was the, how do we find out the xi in bisection method? Can you recall? It is xi is equal to a plus b by 2. Right? Xi is equal to a plus b by 2. Whereas in RegulaFalsi method, xi is equal to a into f of b minus b into f of a by f of b minus f of a. So just remember this. How do we find out xi in RegulaFalsi method? A into f of b minus b into f of a by f of b minus f of a. Then next thing we do is finding that f of xi. So let's continue solving. Now in the first iteration, the interval is 0, 1. So we have got from here. So f of 0 into f of 1 is less than 0. So we have got that this is the interval. So what was f of 0? This was giving us the result less than 0. And f of 1, this was giving the result greater than 0. So this is our first interval. Now let's find out xi. Now what is xi? 0 into f of 1 minus 1 into f of 0 divided by f of 1 minus f of 0, which is equal to, if you calculate the value, it is 0.7358. So we are correcting to 4 decimal places, right? Because they have given in the question to correct to 4 decimal places. So xi is 0.7358. Now let's see what is f of 0.7358. So we have to substitute 0.7358, right, in place of x. So it's 0.7358 into e power 0.7358 minus 2. So the value of it would be minus 0.4643, which is less than 0. Okay, so this value is less than 0. So in our previous interval, which was less than 0? 0, right? 0 was, f of 0 was less than 0. So in our next interval, we already got something else. We got other x, which is also giving us less than 0. So we will replace this less than 0 with our new x. 0.7358, 1 is our next interval. Okay, if at all this was giving us greater than 0, then we would have replaced to 1. Okay, but since it is giving us less than 0, so this new xi will be replacing the one which was giving us less than 0. So f of 0.7358 gives us less than 0 and f of 1 gives us greater than 0 as usual. So now it means our root lies between 0.7358, 1. So this is x1. I keep forgetting to change it. Now x2. Now x2 is a into f of b. Now this is our a, this is our b. Previously this was our a, this was our b. Now x2 is what? A into f of b. 0.7358 into f of 1 minus 1 into f of 0.7358 divided by f of 1 minus f of 0.7358. So the value of this is 0.8395. So now what is f of 0.8395? When we calculate it, so we get minus 0.0564, which is less than 0 again. Okay, so we are going to replace, so this x value is giving us less than 0, right? So what we will be replacing? We'll replacing what was giving us less than 0 in the previous interval. So 0.8395, 1. So now this gives us less than 0, f of 1 gives us greater than 0. This is a, this is b. You know, often while I was solving, I was accidentally replacing our a value with 0.0564. No, I'm just telling so that we'll not get confused. We have to replace x values. Okay, so now let's find x3 with our new a and b with our new interval. So x3 is 0.8395 into f of 1 minus 1 into f of 0.8395 divided by f of 1 minus f of 0.8395, and the value is 0.8512. Now f of 0.8395, f of 0.8512, right? So f of 0.8512 is equal to how much? It's minus 0.0061. This is also less than 0. So now what we will be doing? We will be replacing whatever was giving us less than 0 in the previous interval, right? So I think I'm someone who can't draw the lines properly. So yeah, so this was f of 0.8512. Our new x value is giving us less than 0, right? So now in the fourth iteration, since this is giving us less than 0, this x is giving us less than 0. Previously whatever was giving us less than 0, we are going to replace that with a new x value. So 0.8512 comma 1. So this was giving us less than 0, this was giving us greater than 0. This is A and this is B. Now let's find out x4. x4 is equal to 0.8512 into f of 1 minus 1 into 0.8512 divided by f of 1 minus f of 0.8512. Now the value is 0.8525. Now what is f of 0.8525? So the answer is minus 0.0005, which is again less than 0, but we are already getting a feeling that this is about to become 0, right? Yeah. So but still this is giving us less than 0, right? Our new x value gives us less than 0. So in our fifth iteration we are going to replace what was giving us less than 0 with our new x value. So 0.8525 comma 1. So this is less than 0, this gives us greater than 0. This is our new A, this is our new B. Now let's find out x5. x5 is equal to 0.8525 into f of 1 minus 1 into f of 0.8525 divided by f of 1 minus f of 0.8525. Yes, so which gives us 0.8526. Now what is f of 0.8526? Correcting to 4 decimals, no, this is approximately giving us 0. So a new root is 0.8526, right? Since f of 0.8526 is approximately giving us 0, the root is 0.8526, correcting to 4 decimals. So in the next video we'll solve few more questions on RegulaFalsi method followed by PYQs. So I hope this solving is clear. I hope this method is clear. Please subscribe if you find this helpful. Thank you.